Hey guys, and welcome to the 2020 HSC Advanced Math paper walkthrough. In this video, we'll cover the multiple choice section of the HSC paper, and in the coming videos, we'll go through the long response. Now, before we dive in, I wanted to talk through some general strategies on how you can maximize your marks in the HSC exam. So the 2U paper is 3 hours long, and that's actually plenty of time to complete this exam. Of course, you should still pace yourself and not move too slowly, but there's no need to rush. So your main focus needs to be on accuracy, especially since the margins for getting a band 6 isn't as big as it is in extension 1 or extension 2. My advice would be to allocate about 1.5 marks per minute, spending a little bit less time on easier questions and a bit more on more difficult ones. Now, since the 2U exam is 100 marks all up, this should take 150 minutes to finish and leave you with 30 minutes. You can use this 30 minutes to check over your work and spend it on any questions you were stuck on or were unsure about. My advice would also be to check your answers as you go. As you finish each question, just look over your working and see if you did it right. This will mean that by the time you check your work at the end, you would have already found a lot of the mistakes. And plus, once you finish the HSC exam, you might start celebrating a bit too early and may not be bothered to check it thoroughly, so it's a good idea to check as you go. Another tip I wanted to give you guys is what to do with reading time. If you already have some strategies that are working well for you, then stick with them. If you don't, this is what I would do. Start by reading through the paper in order. Some students like to start from the back, but I think it helps you organize your thoughts better if you start at the front. Now, if you read it in order, you'll encounter the easier questions first, and this will help calm your nerves and help you build your confidence. Then as you move to the later, more difficult parts of the paper, read through the questions carefully. Doing this will help your brain to start subconsciously working out ways to do them so that once you come to those questions, you can solve them more easily. Alright, so let's dive right in. So the first question, it's just a simple domain question. So it's asking us which inequality gives the domain of y is equal to square root 2x minus 3. So with these questions, we know that for a square root, the inside needs to be greater than or equal to 0. So you could probably do this in your head, but we'll solve this out. So 2x minus 3 will be greater than or equal to 0. So 2x will be greater than or equal to 3. And x will be greater than or equal to 3 on 2. So that's part D. So this brings me on to another thing. So usually there are two types of multiple choice questions. One type where it's just better to go and solve it and then see which of your answers matches up with the options. The other is to have a look at the options, because sometimes the questions in multiple choice can be pretty difficult to solve. So you need to sort of go via a process of elimination by looking at the multiple choice and then eliminating which of the options don't work. And then you can plug in some of the options that you think are valid. Okay, so now let's have a look at question 2. The function f of x is equal to x cubed is transformed into g of x is equal to x minus 2 whole cubed plus 5 by a horizontal translation of 2 units followed by a vertical translation of 5 units. Which row of the table shows the directions of the translations? So we can see that this component will be the horizontal translation, and since it's a minus, this will be a horizontal translation to the right, and then we have a plus 5, and this outside value determines the shift, the vertical shift. It's plus, so that that means it will be a shift upwards. So the right option then in that case is B. Okay, so let's move on to question 3. John recently did a class test in each of his 3 subjects. The class scores on each test were normally distributed. The table shows the subjects and John's scores as well as the mean and standard deviation of the class scores on each test. Relative to the rest of the class, which row of the table below shows John's strongest subject and his weakest subject? Okay, so to do this question, we need to calculate the z-score for each of the subjects, which will tell us how far away John is from the rest of his peers. So let's go and quickly do that. So for French, his z-score will be given by 82 minus 70 divided by 8, which gives us 1.5. Then if we calculate the z-score for commerce, so that'll be given by 80 minus 65 divided by 5. That gives us 3. And then if we calculate the z-score for music, we have 74 minus 50 divided by 12 this time. And this gives us a z-score of 2. So you can see that commerce has the highest z-score and French has the lowest z-score. So that means for commerce, he's outperformed the rest of the grade by a larger margin than compared to the rest of his subjects. And for French, he's outperformed the rest of his subjects by the smallest margin. So that means commerce is his relatively strongest subject and French is his relatively weakest subject. So this gives us option A. Okay, now moving on to question 4. So we have the integral of e plus e to the 3x. So e is actually just a constant. So if we integrate e, we just need to slap on an x. Now if we integrate e to the 3x, we'll have e to the 3x and we just need to divide that by 3. And then we have our plus c. So this gives us option B. Now, sometimes with the multiple choice questions, they serve as a bit of a reminder for the rest of the paper. So in this case, I will take the reminder to be adding this plus c. And you would have known throughout your studies that this plus c is a really common mistake that students make. And maybe at some point you've made a mistake, but hopefully this gives you a bit of a reminder to add in your plus c's when you come to those integral questions later on. Okay, question 5. Which of the following could represent the graph of y is equal to negative x squared plus bx plus 1, where b is greater than 0? So now we're kind of stepping into the harder questions. So from question 5, this isn't an obvious question like the rest have been. So let's have a look at how we can do this. Now, if we first take a look at the coefficient of x squared, it's something negative. So that means this has to be an upside down parabola. And we can immediately eliminate option A and option B. So now let's have a look at option C and D. So the difference really between these is where the graphs are positioned. Option C, the graph is positioned to the right more so, and option D is positioned more so to the left. Now really what the differences here are where the vertices are for these two parabolas. For the x, it's on the right hand side of the y-axis, and for D, option D, it's to the left hand side of the y-axis. Now what we can do is actually calculate the vertex, and we know that the vertex is given by x is equal to minus b on 2a. So in this case, our b value is just straight b. That's the coefficient of x, so minus b. And then our a value is minus 1. So we have 2 times minus 1, which is just minus 2. So let me just write that as minus 2. And this simplifies into b on 2. Now we know that b is something positive. They told us that b is greater than 0, which means that this is a positive value overall, which means that the vertex needs to be sitting on the right hand side of the y-axis. So this then gives us option C. Okay, now moving on to question 6. Which interval gives a range of the function y is equal to 5 plus 2 cos 3x? So the usual range of the cos function is from negative 1 to positive 1. So if we multiply that by 2, we increase the amplitude by a factor of 2. So our range for 2 cos 3x just becomes minus 2. Y is between minus 2, positive 2 and 2. And what we've also done to this graph is we've actually shifted it up by 5 units. So that means we need to add 5 to both minus 2 and positive 2. So that gives us 3. Y is between 3 and 7. And that there is option B. So 6 is B in set notation. Okay, now let's move into question 7. The diagram shows a graph of y is equal to f of x, which is made up of line segments and a semicircle. What is the value of the integral of f of x between 0 to 12? Okay, so in this question, they're asking us specifically for the integral and not the area. So if you have a look at the diagram, there are some negative or regions below the x-axis, which will produce negative area. Now, if the question was asking specifically for area, we would need to take the absolute value of these negative areas and then add it to the areas that are above the x-axis, which would be positive. But since they're asking us just for the integral, these negative areas will subtract from the areas that are above the x-axis. So what we'll do is we'll break this into a few different shapes. So we've got a big rectangle here, we've got a semicircle here, and we've got two triangles here. I want to start with these triangles because if you have a look, they would have the same area. So this triangle, this first triangle here, has a base of 2 units and a height of 3, and so does this triangle here. And since this is underneath the x-axis and this is above, the areas from these two triangles will cancel each other out. So we won't even bother trying to calculate those areas. Now let's have a look at the area of the rectangle. We can see that it has a width of 3 units and a length of 8. So this would be 24 units squared. And now we just need to calculate the area of this semicircle. We can see that it has a diameter of 4 units. So if we have a look at the area, that would just be half times pi times, if the diameter is 4, the radius would be 2, so 2 squared, and this comes out to 2 pi. So the total area is 2 pi plus 24, which gives us option A. Okay, now moving into question 8. The graph of y is equal to f of x is shown. Which of the following inequalities is incorrect? So here, for this question, we've got the second derivative, we've got the first derivative, and we've got the value of the function all at x is equal to 1. Now, if we have a look at the multiple choice for this question, the options, we have two distinctions. That's the first thing that I see. So the difference between A, B, and C and D is the fact that these first two are saying that the second derivative is something negative, and these two are saying that the second derivative is something positive. So if we actually take a look at the graph, this graph is concave down. So that means the second derivative at 1 will be something negative. So that immediately knocks out option C and D, which say it's something positive. So let's have a look now at the differences between option A and B. We can see that the difference comes down to whether f-1 is bigger than the value of the function at 1 or the other way around. So in order to do this, we need to actually find an expression for the gradient at x is equal to 1, or f-1. So to do that, what we'll do is we'll first draw a tangent to this point. Now remember, the gradient of a graph at a particular point is just the same as the gradient of the tangent at that point. So the graph passes through 2 points. So the first point is obviously just 1 and f of 1. F of 1 is the y value since the function is given to us by f of x. And we also have this other point here. So this is just the y-intercept. So the x value of the coordinate will be 0. And we'll say that the y value here is b, where b is something positive. So if we want to calculate the gradient of this tangent, we'll have to go back to the gradient formula. So f-1 will be given to us by y2 minus y1. So f of 1 minus b divided by x2, which is 1, minus x1, which is 0. And this gives us f of 1 minus b. So since b is something positive, we're actually taking away from f of 1. We're taking some value away from f of 1 to get to f-1, which means that f-1 will be of a smaller value than f of 1, which means that the answer to this question should be A. Okay, let's move into question 9. Suppose the weight of melons is normally distributed with a mean of mu and a standard deviation of sigma. A melon has a weight below the lower quartile. So the lower quartile refers to the bottom 25% of the distribution, but not in the bottom 10% of the distribution. Which of the following most accurately represents the region in which the weight of this melon lies? Okay, so in order to do this question, what we need to do is to actually work out what each of the standard deviations correspond to in terms of percentiles. So let's draw a quick diagram. So we have one standard deviation here, 2 there, and then 1 there, and then 2 there. So we know that between 2 standard deviations, we have 95% probability. So that means in the tails, we have that remaining 5%. So per tail, we have 2.5% of the probability. So that means the 2 standard deviations to the left represents the 2.5 percentile, 2.5% percentile. So one other thing is that in the middle, at the mean, we have the 50th percentile. Now, between the first standard deviations, we have 68% of the probability, which means that between the first standard deviation on the left and the mean, so the middle, we have half of that, so 34%. Now, in order to work out what percentile is represented by the first standard deviation to the left, we need to subtract 34% from 50%, and that gives us 16%. So that means this one standard deviation to the left of the mean represents the 16th percentile. So that means coming from the far left, so at negative infinity here, would have the 0th percentile. The second standard deviation represents the 2.5% percentile, and the first standard deviation on the left represents the 16th percentile. Now, if we want something that's between the lower 25% percentile and the lower 10% percentile, we just need to locate where these would roughly be on a diagram. So if this is the lowest 16th percentile and this is the 50th percentile, the 25th percentile would be somewhere in the middle, so say here, and the lower 10% would be somewhere between here and here, and so we'll say roughly it would be here. So we're looking for this region here, and the diagram that's most similar to this is given by option C, which is the answer to this question. Okay, now let's move into question 10. So this is probably the hardest question in the multiple choice section, and hopefully you've noticed the trend in questions getting harder from start to finish. So let's have a read of this question. The graph shows two functions, y is equal to f of x and y is equal to g of x. Define h of x as f of g of x. How many stationary points does y of h of x have for x's between 1 and 5? Okay, so in order to work this out, we need to think about when we have stationary points, and that's when h of x is equal to 0. Now, we know that h of x is equal to f of g of x. So h dash x will be equal to f dash g of x, and we need to multiply this by the derivative of g of x since we're applying the chain rule. Now, there are two components to the derivative, and we need to think about how many times each of these components are equal to 0. So let's start with the easier one, g dash x. So that's the parabola here. And we can see that it has one stationary point at x is equal to 3. So this just has one stationary point. Okay, so this first part is a little bit more tricky to work out. So first we need to think about how this is actually happening. So this is a composite function. And what that means is that the y values of g of x, so the parabola, are being plugged into the values, the x values of f of x to produce a composite graph. So we need to think about where the stationary point of f of x is. It's slightly less than x is equal to 1, and it's somewhere around here. So that means when a value of, say, 0.7 roughly gets plugged into f of x, that's when we produce a turning point. So we need to think about how many times we input a value of 0.7. And if we look at the parabola, 0.7 occurs, a y value of 0.7 occurs twice at these 2 points here. So that means we plug in a value of 0.7 twice into our formula of f of x to produce this composite graph, which means that we produce 2 turning points from this first component. So altogether there's 2 plus 1 turning point, so 3 turning points. So that means the answer to this question is D.